However, in this spreadsheet, this is really a long story. Actually, I'm not sure where to start exactly. Basically, a long time ago, I've replicated a Houdini animation using geometry nodes. At that moment, I've complained in my Discord server that this method was too slow because it converts points to volume, volume to points, etc. Later, there are so many things going on, I end up not making a tutorial for this. Today, we're going to talk about this simple animation, and I'm going to use different methods to approach this. Which method is better, it depends on your choice. And more importantly, to see how we can actually improve the whole thing using different methods. So let's start. So here we're in Blender, and basically the first thing that we're going to do is to replicate the Houdini tutorial. Firstly, we need to distribute the points clouds, basically within the volume. So as I explained in my other tutorials, when you distribute the volumes, you need multiple faces. In the past, I've talking about using a cube and then use the array modifier object offset. In this particular case, I'm just going to do things a little bit easy, and then I'm increasing the count. And then I have basically a cube, a lot of faces of the cubes. And then I'm going to the noding, geometry nodes, add geometry nodes modifier. There are basically two ways to distribute the points. One is to subdivide. So you have the points on each vertices, then you basically giving a kind of grid. Another method is point distribute. Then the point becomes very random, but it's kind of very fast because when you subdivide, it creates a lot of geometry, which is not nice. But if you use point distribute, it's just a very fast point cloud. And I'm going to hit the amount into density into 1000. The bad part of the point distribute is you do not define the amount of points. The good part, however, is even if you scale that up, the points amount will also scale that up. So there are pros and cons with this method. But the whole point is that if you do not know the amount of points that you are instancing, then you go to the point clouds. Then you can see there's a row count is about 180,000. Okay, so this is the idea. You can determine the amount by yourself, but I think that's why I think it's better than subdivide, because I don't know how much subdivision you need in order to achieve this high amount. Anyway, next step that Antagma does is that he distributes points within this cloud. So assume this is not a tons of points, but a real cloud or volume. Then next step is really distribute the points. So we're going to take another point to distribute, and I'm going to take the 0.05. And by hitting this screen icon, I'm actually going to see the output that I'm giving. One thing you need to notice is that if this geometry is not connected to any place, it does not actually show where you're actually outputting. So by 0.05, I'm distributing 7 points. I think this is good enough because we will see the results later. And then I'm going to basically measure the how this points clouds relative the distance to each point that we distribute, like 7 points in total. In this case, I'm just going to use the upper, attribute the proximity node, and the upper goes upper, down goes to down, and then I'm going to switch the type into points. And we only care about the distance, and so this is it. Next step is just to put a sine wave on the top of this distance value. Sine function is a very tricky function. I've made a preset in animation node, so I think I will make one in geometry node as well. I just forgot, so I do not have that preset on my hand. So we have to do this. You take an attribute mass and then take it to sine. You might think, okay, this is already finished. But the reality is that there are several important parameters about the sine wave that we have to specify. So I'm going to duplicate this attribute mass for 3 times in total, and shift select the most beginning and the last attribute mass. I'm going to hold Alt and then select them to multiply, and then select the second attribute mass, or shift click. And I'm going to actually, this one should set to add. Okay, and then hold Alt, change that to float. So the second number goes to float. You don't necessarily follow it exactly, just get all these kind of settings. Even you're not shifting select is fine. It's just I think this is how it makes things convenient. And I'm going to multiply 1 and add 0. So you might think, okay, what does it do? Not doing anything. Everything multiply 1 is still everything. So, and we're going to control J to add a frame. We can add a label, just to call that sine function. because we will change all these kind of parameters later. Just to know some basics about the sine function, you can actually easily check everything where in Wikipedia. Basically, sine function is a function that starts from the 0 and it peak at the positive 1 and negative 1. So it crosses the 0 for multiple times. And more importantly, the looping cycle is 2 pi. So this is this is pi, and the looping cycle is 2 pi. So you just need to know it loops every 2 pi's between positive 1 and negative 1. In this case, we can use the point to separate. And we are going to use a compare. So talking about compare method, I do not necessarily know why exactly, but they have the attribute to compare. But you can also take another attribute mass and alt p to make it out from the frame, and then use the greater than. There is no real fundamental change. The only difference is probably for the attribute to compare, you can compare with vector and color boolean. But while attribute mass is really just a mass, and then we're going to hit the D, everything disappears. Oh, what happens, my dear? Why everything disappears? Here, one thing what we can try is to actually increase the frequency, and then immediately you can see how this looping actually occurs. Okay, so these parts, so whatever happens, these parts is within the sine function because it's before the sine function. So the multiply means increasing the frequency. So higher the amount, increase the amount of ridge or empties you see. Okay. The second add is actually the animation part. You can see once you are increasing these values, you can see how these kind of points either move inward or outward. I think it causes an illusion at some point. So I don't know, but you can try by yourself. Basically, I guess yes. If you're increasing the number, it seems like they're moving inwards. So which means if you're decreasing the number, they are moving outwards. Okay, just to know that if you're increasing the frequency too much, it will cause illusion. Another multiply is actually talking about the amplitude. In this particular case, however, it does not really change because once we are comparing that, there is it does not really matter with your value. You only get 2 results: yes, no. Then this is how compare really works. And the yes goes to the second socket, no comes to the first socket. It does not really make a fundamental difference. It's just a switching between 2. I don't think it's very interesting in this case. Now whatever we're seeing is just the kind of points. They are not really there. It's just a virtual. It's just made for you to visualize better. But there aren't anything there. So you can potentially actually instance a UV sphere and take that to 4, because you do not want to crash your computer with high geometry. So I think a kind of 4 sphere is good enough, or you can actually deal with. You can change the parameters later, subdivide or whatever. And then you can use point instance. So this is one way to do. The only thing is the scale is too large, then you can use the point scale. Just to notice the amounts of your instance is extremely large. So it's kind of a bit lag. But this, I think this is essentially the best method they can think of. Within these point scales, in order to change 3 axes at the same time, so I'm just going to take out 0.15. Plug that to factor. Then you get a kind of stuff, and we can actually change the yeah, this is something that you can manage by yourself. Just 0.07, something like that. You can also increase the separation so the points from points. Oh, this is Christ. I think you can actually manage this by yourself, just to know the point of sine function. Okay, so we have this kind of structure. So this is the instancing, but the instancing does not really look like good. You cannot count all this kind of blobbing stuff. Looks very ugly, but the Houdini result looks kind of very awesome. What they actually do is they put the volume and everything. So just to give you kind of idea, let's firstly disable this object because it looks kind of hurting my eyes and hurting my viewport. What Houdini does is the point to volume. and the volume to mesh. I'm not going to directly show you because you can plug by yourself. If it does not really give you the results, you have to deal with all these kind of parameters: density, threshold, voxel amount. I have to warn you, it's extremely slow. Extremely slow. It also depends on computer, but it is really slow. Much slower than instancing. At least in instance you can still work. In volume you can barely work anything. And it's the results is kind of very tricky as well. Here we've basically finished the one methods talking about this animation. But there is one important thing I want you to realize. The actual way we're the actual thing that we're actually doing with this point distribute and attribute proximity has a specific name about such kind of pattern, which is called Voronoid. Okay, so we do not necessarily to use this method, which I think is very interesting, but it's really not necessary. There is basically a way that are not attribute proximity. Basically, you just attribute the sample texture. Put the geometry in, and then take the textures, set the texture into Voronoid, and then we take the position, and then we are typing D, and it just looks kind of very bad. The reason is simply just you do not have enough size. So once you have enough size that fulfill the basic how should I say, basic requirements of the sine function, then it will actually be fine. Actually, if you just type the 0.95, I think you still can actually get a kind of result. Depends on your frequency. Actually, probably not. Let's just type that to make your life easier, and then to make the frequency down so that you can see the result clearly. I think this is a little bit better than the previous one because it looks kind of more obvious about what's actually going on. I'm not sure why, but so this is kind of idea. The bad part, however, is one part you cannot really directly slide. I do not know why they put this kind of limitation, but it's still valid that if you type a number so that you can get all these kind of values, and then you increase the frequency, so it looks kind of nicer, cleaner. Another bad part is that you do not previously, when we are using this attribute proximity method, yeah, we need a geometry. So once we have this point distribute attribute proximity method, that you are clearly knowing that you're instancing 7 points within these volumes, and so on and so forth, you are doing this kind of animation. But if you're using the Voronoid texture, you're not really, you don't really know how many points you distribute within this volume. I can guess it's like a 3, but I'm not sure. I'm actually getting confused. Probably only 2 this here. Yeah, 3 points. So you do not really know the number. Is that very important? I'm not sure. It depends on how you would like to do. Okay. Another thing is, depends on the attributes, you can actually determine whether it's thin or thick. So this is part that I forgot to tell you. So sometimes you would like to have a more obvious ridge, then increase the count. Just not increase that to larger than 1, otherwise it's just okay. Okay. So having this is good enough. There's one more thing that I would like to discuss. Actually, here we're trying to use the Blender 3.0 alpha. So I switched to 3.0. Is that how to actually get different color? And we're going to make several changes. Previously, I already said that this is a sine function. Then I guess I'm going to make a group node presets in the future, so you know how to build that. So you put the values back in, and we're going to take the first attributes and the second attribute to a different socket, and keep doing the same, link everything. This is kind of very bad and sounds kind of awkward, but you just have to do. And then finally take the amplitude. This is just the preliminary, the group nodes, just so you don't have to be serious, but let's just take a little bit name so that we know which value is doing which, and the result. and take the amplitude. Just to know that in this actual tutorial, we're not going to use the amplitude. Actually, at least I don't think so. Although amplitude is kind of important when we're talking about this math. And I'm going to delete this sine function. Okay, so duplicate this sine function. I'm going to take a math value. One take to frequency, the other is taken to the add. I'm going to multiply the 2 times, and you will see why. Take that to frequency, and here we are going to distinguish the 2 results. So let's just name as D sine wave, and D double, which is DD. Okay, and frequency animates. Okay, I think we get everything right. So then I'm going to take the 0, take another as 0. Okay, so one is DS, another is DD. Sounds kind of dumb, but this is a necessary step. So everything goes back to volume because the name does not really match. So we're going to distribute these as at this moment, and the result is not really good because the value is not correct. So once we increase the values, we had everything back. Okay, you might still think, okay, what's the point of this entire whole thing? And we will see later. Actually, basically the idea for different color in this case, because the important part is not getting color. If I just want the color, I can use cycle. But if you want to use Eevee, it's kind of very tricky. The vertex color methods does not really work for instances. So here we are going to use a new function which is in 3.alpha, which is material assign. What we need to do is very simple. Previously, the reason I managed to create a DD is because we are creating a double frequency of sine wave from DS, which it means if this region is covered by DS, which is shown in this kind of region, and DD is to cut this DS region into half with this double frequency. So which means within our DS, I'm going to point separate one more time, but this time we're trying to use DD. Okay, and at the first line we're going to take the object, and the second line we're going to do basically the same. So you can duplicate or make it in group nodes. To me, it does not seem very different. And finally, we're going to join the geometry. Okay, so it does not look like to be seem very different. But once if you deal with the color, everything becomes so different. So you take a material assigned to 1 and take material assigned to the second. And in this case, you do not need to worry about the selection because it's already the selection is already made upon this point separate. And you cannot directly add a material, so I think we need to add a materials here and add another socket there and another material. So one is called red, and the other let's just call it white. And so one material is just going to set that to red. So let's see the result that we immediately get. And red, the other is white. Actually, we already see the result. So this is how you can get different color. Is this a very nice method? I don't think so, because the materials are different. If you would like to synchronize the stuff, you probably need to do a lot of other work. For example, one thing that you can do is to put this red into the object, to take into a group, so that all the property will share across the material. If the white is using the same node group, so node group. But this time we're going to change to white and saturation down. So this is one way to deal with that. I do not really like this method, but it works. It synchronizes the values, because if you would like to take anything, you can just where is that? So you can just change, if you would like to change the value non-specifically or pass the same value across two different material, then you can change within the group. Otherwise, you can output that. This is kind of idea. I do not really like this method, but it works. So the point is that if you're just doing kind of statically, no color transition, then this material assign can do such kind of job for you. If you're doing really the color transition, then I think currently Eevee cannot do this function for you. So you either try alternatives or just wait the development. So this is really all about it. So I hope you enjoyed this tutorial. See you next time. Bye bye.